At 11:59 tonight, the moon is exactly where it should be. At midnight, it is gone. Not exploded. Not falling toward us. Just removed, as if someone deleted a layer from the sky. For about 1 second, nothing changes. The last moonlight is still crossing the 384,000 kilometers between us. Gravity's change also cannot arrive faster than light. Then the sky goes empty, and the first surprise is what does not happen. You do not float. Earth does not shoot away from the sun. The oceans do not leap into space. Our planet keeps rotating, and tomorrow still arrives on schedule. The moon is enormously important, but not in the cartoon way. Its real influence is quieter, slower, and woven into systems most of us never notice. Start at the coast. The moon does not simply pull the ocean upward like a giant vacuum cleaner. Its gravity pulls slightly harder on the side of Earth nearest to it, and slightly less on the far side. That difference stretches the oceans into broad tidal bulges. As Earth turns through them, coastlines experience rising and falling water. Delete the moon and you delete the main driver of that rhythm. But the tide already moving at midnight does not hit an invisible wall. Water has momentum. Ocean basins resonate. Coastlines, seafloor shape, wind, air pressure, and currents all keep pushing it around. So there is no single, neat global wave called the last tide. Every coast starts from a different point in its cycle. Some places are near high tide. Others are near low tide. The transition would be messy and local. Then the familiar lunar pattern fades. Not all tides vanish. The sun also stretches Earth and its oceans. Solar tides are weaker than lunar tides, but they are real. Storm surges, winds, and local basin effects remain too. The result is not a tideless planet. It is a planet whose strongest celestial metronome has stopped. Within days, tide tables become historical documents. Ports that schedule deep draft ships around high water need new operating rules. Fishing grounds that depend on tidal currents change. Mudflats stay exposed for different lengths of time. Salt marshes flood differently. Channels that were regularly flushed begin behaving in unfamiliar ways. And the moon's most dramatic victims may be living in the narrow strip between land and sea. The intertidal zone is a place built around repetition. Wet, dry, cool, hot, submerged, exposed. Again and again. Mussels close their shells. Crabs time their movement. Shorebirds arrive when feeding grounds emerge. Tiny organisms release eggs and larvae when water and lunar cycles line up. Take away the lunar signal and you do not instantly kill everything. Nature is not a row of switches, but you change the timetable that entire communities evolved around. Some species would follow the remaining solar tide. Some would use temperature, daylight, or internal biological clocks. Some would mistime feeding or reproduction. Predators would discover new opportunities. Competitors would move into new territory. The shoreline would not become empty. It would become different. Now look up, although there is much less to see. A full moon is not daylight, but it is the brightest natural light in the night sky. Without it, every clear night outside cities becomes a moonless night. The Milky Way looks stronger. Shadows from moonlight disappear. Human stargazing improves. For many animals, that is not a cosmetic change. Moonlight changes who can see whom. Some nocturnal predators hunt more efficiently in bright nights. Some prey hide because they are easier to spot. Other prey animals use moonlight to detect danger. Birds, insects, fish, mammals, and corals can respond to lunar light or lunar timing in very different ways. There is no universal rule that darkness helps prey or moonlight helps predators. It depends on the eyes, habitat, and strategy of each species. Remove the moon, and millions of nighttime negotiations get renegotiated at once. Humans lose a clock too. Months are not identical to the lunar cycle, but the connection is written into the word. Many religious calendars, festivals, planting traditions, fishing practices, and cultural rituals still use lunar phases. A calendar can survive a missing object. We would keep calculating the phase the moon would have had, just as we preserve old units and conventions. But eventually, full moon would become a phrase describing something no living person had seen. That is the immediate Earth. Darker nights, weaker and altered tides, confused coasts, changing ecosystems, and one enormous blank space in human culture. The truly planetary consequences take much longer. Right now, Earth spins once in about 24 hours. The moon's tides create friction. That friction very gradually slows Earth's rotation, while the moon moves outward by about 3.8 centimeters per year. If the moon disappears, Earth does not suddenly spin faster. A moving planet is not a spring-loaded toy. Instead, most lunar tidal braking stops. Solar tides continue slowing Earth, but the long-term rate changes. Over geological time, future days would not lengthen in quite the same way they would have with the moon. Then there is Earth's tilt. Our rotational axis is tilted about 23.4 degrees. That tilt creates the seasons. It is not perfectly fixed. Gravitational interactions make it vary slowly. The moon helps keep that variation relatively restrained by changing how Earth's spin axis precesses. Roughly, how the axis slowly traces a circle in space. Classic simulations of a moonless Earth found that the planet's tilt could wander through a much larger, chaotic range. Later work shows the exact future depends on the other planets and the starting conditions. This is not a prediction that Earth flips sideways next Tuesday. It is a warning about deep time. Across tens of thousands to millions of years, a larger tilt could make seasonal sunlight far more extreme. Poles could receive intense summer sun. Regions that now have mild seasons could swing harder. Ice sheets, ocean circulation, and climate zones would respond. Not once, repeatedly. Civilizations could adapt to changes that slow. Species can evolve. But a less stable planetary tilt makes the climate's long-term rulebook harder to rely on. And there is one final twist. If the moon had never existed, this story would be completely different. The giant impact that probably created it was part of Earth's early history. The moon influenced the length of ancient days, tides on early coasts, and the physical environment in which life evolved. A moonless Earth from the beginning might not produce the same oceans, climate history, or life that could stand here and miss it. But our scenario is stranger. Remove the moon now, after Earth has spent 4.5 billion years adapting to its presence. That means the first night is not an apocalypse. It is a system update with no rollback. The beach still has water. The sun still rises. Your alarm still works. But the old rhythm is gone. At first, we would notice the empty sky. Then the ports would notice. The animals would notice. The coastlines would notice. And long after every person who remembered moonlight was gone, the planet itself would still be adjusting to the missing partner that once quietly kept time.